Am I on? Oh, good morning. Morning. How are y'all doing? Good. Everyone well rested? Yeah? Anyone go out last night? Yeah? But you're well rested? We're going to touch base every morning. And we'll see. I want to welcome you all to Impact 2020. We're so excited to have you here. My name is Amanda Headley. If we haven't met, if we haven't personally met, I look forward to meeting you over the next couple of days. And Michelle Cervantes and I are here representing the CMG staff. And if you need anything at all, please come to us. And we'll be happy to assist you and point you in the right direction. So again, we're just so excited to be here. The Impact Conference is a year-long planning adventure, so it's great when it's finally launched. So I see some new faces in the audience, so I want to play a very quick game that I played it at my wedding. The DJ did it. He was much cooler than I am, but so everyone is here at Impact. So everyone raise your hand. If this is your first Impact conference, put your hand up. Oh, so you do have some good new faces. Love it. Second Impact conference, put your hand up. Okay. Fifth. All right. 8th. 10th. 15th. 20th. Ish.
I don't know. Oh wait, Debbie said what year?
Debbie wins.
1979.
1979. So that would have been about the 4th Impact Conference. Wow. And I bet you've spoken at like 50% of them probably.
Off and on, it depends on whether you have people to sponsor you or not. So that has more impact than whether you have something to say or not.
Awesome. Well, for everyone returning, glad to see you again. For all of you new people, I hope this is not the last time we see you. This is the 45th Annual Impact Conference, and if you haven't looked up the history, you can find it online, but I had the opportunity this past week, I came across this fascinating piece of paper that was written in the 80s by some, it was a session that they were doing at a conference, at one of the Impact conferences. And it was in 1999, it was fall of 1999, and it was giving you a snapshot of what was going on in tech in 99 and how CMG was responding. There was, a few comments about the Y2K bug and were we gonna make it through, which I thought was fun. But it was an interesting read to me because they were reflecting, they had a lot of founders and they were reflecting on the first 20 years of the organization, and everything came back to me, the things I hear today, which were that this was a place for exchange of real information, so you could gain practices and tools and techniques that you could take back and immediately apply in your jobs. So it was all about that peer-to-peer exchange and all about the learning. So I think that that's what makes the conference special. And as you being a part of it, I know that you participate actively in that, so I learn from others because that's what CMG is. So thank you. Before I bring, I do want to spend a few minutes to thank our sponsors. We couldn't do this conference or have CMG without some great partners. So our platinum sponsor is Broadcom. They're returning to this conference for the second time this year. Their product portfolio serves multiple applications within the primary target markets, including data center, network. And they are represented here, I'm sure you've seen their booth, but they're represented on our agenda this week with engineering team lead Jyotsna Chaturvedi, who's going to be presenting on self-healing trifecta, earlier warning, faster RCA, and automated resolution. Her session's on Wednesday, so I hope you'll check that out. Also, Moviri is here. I'm sure you saw them at their booth. They have been a partner of CMG for the Impact Conference and at the regional level, mapping your successful cloud migration, changing the rules of engagement, supporting business growth through capacity planning at Cerner, and performance. Thank you. Performance is not only about response time. I also want to thank Data Kinetics. They're a global leader in data performance and optimization solutions, and they work with a lot of banks, brokerage, credit card, insurance, and healthcare companies. They are on the agenda. We're actually going to get to hear from their CFO in a session, which I think a lot of people will find valuable. It is a lot about justifying cost of IT expenditure. So I know that is probably something many of you struggle with within your organizations, where you know where there's investment that needs to be made or changes and you need to justify it up to the organization. So lastly, I want to also just give a shout out to our booths out there in our Tech Expo. Lean IX, Luminix, Scale Computing, and Quick Start. These are actually all four of these sponsors are new to the conference this year, so we're really excited to have them here. If you haven't met them, please do go say hi and welcome them to Impact and here at Impact for the first time. We also this year partnered with several community partners. So these are organizations, many of them are similar to CMG but might be in different areas. But we partnered with them in order to She is with MathWorks, but I'm also pleased to say she is our 2020 board chairwoman. Anush?
Well, thank you, Amanda. Really big thanks from everyone to you and your team for pulling together what is shaping up to be an exciting conference. We're glad to welcome all of you here and want to acknowledge the work by you who is here and by your team. Thank you. While we acknowledge and celebrate our team, we also are eager to hear your feedback, both now as the conference is starting up, about what you're expecting and how we can bring you, what we can build for you, and as the conference goes on and towards the end, please be fun. Now, I'd love to take a few moments to share with you what we have been up to for the time we haven't, seen each other in person, so since about a year ago. Now, CMG is a large organization that brings together professionals from across industries and specialties, and there are about, most of them are in this room, some come together at events and on electronic forums and on our social media. So who are we? We have about over 5,000 folks specializing in applications, DevOps, and the cloud. Around 4,300 mainframe professionals. So interesting mix. And I don't know, think about where you find yourself in that map. And in the past year, CMG, some of them in the virtual conference format, which is something new that we have spun up in the past couple of years. And then there were many, in fact, 2,500 or so registrants across these 30. And now, coming to know each other and work with each other. We had our first in-person board meeting for the new year yesterday, so we're off to a great start. And these good folks are, in this room for the most part. We have one or two that are virtually present. And please take the time to seek out these board members and share your vision for how we can serve you here at CMG. And congrats everyone for getting elected, and go make us more proud. Right? And as we look out to the upcoming year, we will see more innovative event formats and activities that our team, and we will look to you as well for your ideas for how to build new things. So our team has thought of some really cool things to our members and our participants, and then some chapter activities and meetups. And yes, the community is one of the things we deliver here, and would love to engage with you. Don't hesitate to send them along, post them on social media. Would love to hear from you. And there are so many ways to participate. There is an obvious way. You can be a CMG member, so thank you if you are. Please, continue to support the organization by breakfast that's coming up this Wednesday. Okay, we would love to both interact with you, hear your ideas, and build something new. CMG Impact 2020. And with that, I just want to shout out another big word of thanks to our volunteers that are visible to us, or not necessarily that visible to us possible. So they review submissions, they write blog posts, they post to social media, they do a lot of things that we appreciate. And who has helped, this conference come into existence for many years, Elizabeth Stahl, and who is our chair of To CMG Impact 2020. Thank you, Elizabeth.
So what I'm going to do now is talk about what we're doing the next 3 days, right? Because we saw that CMG so our wonderful team did an analysis, right, of all the different attendees, and what I think is really cool is it's divided up between a lot of different industries, and a lot of different, we have technology people who that's their prime, area of interest. We have people from all different other industries, consulting, and what's so valuable about that is that when you go and talk to others as you're meeting and networking and stuff, it's just invaluable to hear from all these different areas. I've been to some conferences where it's like everybody's sort of in the same area, and it's not as interesting, I think, as what you can get here. So that's one thing we wanted to point out. So, for those of you who submitted proposals for this, we got more than 150 session proposals. We have a team then who goes through and evaluates, do we think that this proposal would be good? Is this something that our audience would want to hear? And we chose more than 40 sessions here. Some of them, we have people who are repeating sessions for certain ones. A lot of them are individual sessions. As Amanda mentioned, we have people from all over the world. So that's also a major plus here, is that, it's wonderful to be able to hear and talk about what's going on in all different places. And then we also have, what we always try and do with these conferences is make sure we have some sort of local flavor. So one of the things we do is we actually actively go out and find which companies are in the area, ask them, sometimes we get them to participate, sometimes not, but we ask them if they're able to speak. And I think that, or participate, like we have some of the tours we'll talk about. So I think that's so valuable. So besides the value of that, as Amanda mentioned in the beginning, make sure you take advantage of where you are. So you come all this way, and there's lots of great things to do here, so try and at least do something that has the Las Vegas flavor. Debbie and I were talking last night, because we're both hikers, and so she went to Red Rock Canyon. I was in Death Valley, actually, right before this conference. You don't have to go that far. You can also just go down the street, right, and whatever you like to do, eat, gamble, see shows. It's a great place to be, and you can't beat the weather. I'm from Cleveland, so that's why I say that. All right. So, some things that you probably don't want to miss because they're really great. We have morning keynote sessions. So those, I mean, I've been doing this, as Anush mentioned, for many, many years. Been in some ways, along with, where did I see Alex over there in the corner there? I think we've probably been on the program area for probably the longest time. And I think Every year I think, wow, you know, these are just great topics, great speakers, you know, I can't believe that we actually have this content. So again, I am so impressed with the different, you know, everything from, you know, mainframe modernization to AI to, you know, anything in between. It really covers it, really great stuff. So don't miss the keynote sessions. The Tech Expo, where we've been having breakfast, we will also be having dessert and of course receptions, which in the old days we used to call PARs. I don't know if anyone, does anyone remember? Well, okay, so PARs, what does it stand for again?
Performance and relaxation session.
Okay, so you relax and have whatever you need to have there. Is yours a workshop?
Yes.
Yeah, I think that's going to be really cool. I think I'm introducing you. So Anusha's doing basically IoT with how to make your phone. Do you want to mention it? Just because it's so special.
Right. So we call this thing called Pocket AI and IoT. So do you know, on your phone you have lots of cool sensors, and we're going to use the accelerometer on your phone to capture the, you know, spatial XYZ coordinate data that will talk to the Amazon cloud. And then we're going to also post this data to an Internet of Things aggregator, and so figure out who was, I don't know, the most active or who took the most stuff. So sometimes you see people running these sessions, which is an interesting thing to do, but you don't have to. So anyway.
So very cool, just example of a workshop. As long as you don't care about your data privacy and stuff.
Well,
No, I had my husband the other day, because one of my favorite apps is being a hiker, how many miles and steps I do every day. And he's like, you realize that that's all going somewhere, and they know everything about, you know, where and how much and when, and can use that against you. About that a little bit, right? You get a smaller group together talking about something that you're very passionate and intimate. The conference, which I know I'm really excited about, that are local here. So let's see, meeting of the minds, we have cloud and performance engineering. So pick your favorite and go towards, what time, Amanda, those are at 2? This sounds fascinating. So a living lab, so they have it all. Okay, so then that's where they do, like, they test and prepare things in downtown Las Vegas. So at the whole lab. So you can download that. If there's any schedule updates or room changes, that's a good place. Okay, so let's talk a little bit. We have some really fun awards for the conference. So we'll talk about, so I hadn't even seen this till I got here. So there's a TV contest.
So it is, you've probably seen the red tickets.
Yeah.
So if you interact with a partner, ask a question during a keynote session. They were brand new as of this week. So we're excited. Enter the contest. You can earn as many tickets as you can get your hands on. So, and I know who I gave the tickets to start, so we're going to be watching that.
So how do you get those home?
But I'm happy to help you pack it up, and I will Uber with you to the airport or to the FedEx Center, which is probably where you'd like to go.
Audience participation awards. So keep in mind, as you're going to a lot of the different presentations, what was maybe your most useful one that you went to? What was the most fun that gave you the most laughs? The best graphics. So I don't know about most inspiring. The most wow. Some of these overlap a little, but I think these are very cool categories. And then I guess we're going to announce them Wednesday at lunchtime. So you're going to be scored. Keep social. So as we mentioned, we have the hashtag. Do LinkedIn, Facebook, Twitter, Instagram, whatever you like to do. Okay. And there's the formal award that's selected. We actually have a foundation within CMG called the Mullen Foundation. They actually review. In the old days, they used to review, you know, the 30-page academic papers. Now that we're more into the presentation, so they're all from different companies, different academic areas, different specialties. And then what's really great about this award is that to the St. Louis area, or you might get an invite to Chicago or Boston or wherever some of the local areas are that are interested in your presentation. When I was looking at this, I am so impressed by the broad spectrum of sponsors, the number of sponsors, and as Amanda said, we rely on them. We really need this. So any of you that also have some ideas. All right, do I need to go through these again? Are we ready to? So we have Dr. James McCaffrey, and he's going to talk about 4 recent advances in AI and machine learning for IT organizations. And I'm in Washington. He's part of the Artificial Intelligence Group. He has a PhD in cognitive psychology, computational statistics from University of Southern California, USC, BA in psychology. He learned to speak, this is one of the most cool things I think, he learned to speak to the public while working at Disneyland. Bio, he can still recite the entire Jungle Cruise ride narration from memory. So we're going to ask him to get into his presentation, because when you put that in your bio, you're going to have some questions like that. And to tell you the truth, that's great. So we will bring him up here, but I want to remind you to remember to rate your and then you can leave it, if you're doing the printed version, just leave it in the back, or you can drop it off. So 4 recent advances in AI and machine learning for IT organizations. So let's give him a hand.
So, good morning, or rather, welcome aboard, adventure lovers and thrill seekers. I really do remember it, because I said it quite a few times. So, actually, that segues nicely right now, because what are you all thinking right now? You're all thinking, is this going to be a really good talk, or is this going to be a complete death? And one of the things I learned at Disneyland while standing there is people don't mind being tortured. In other words, my talk could totally suck, and you won't mind as long as you know how long the pain is going to last. So, you know, you've ever been to Disneyland or Disney World, and you stand 3 hours with this. It's the unknown. So what I'm going to do is, hopefully, get my thing. Presentation up, and what I'm going to do is find my presentation. While I'm looking for this, do we have any what I would call AI skeptics? Think it's overhyped, buzzword without meaning. So, okay, wait, I see one skeptic. I'm looking for skeptics. Good. Because I think, in the interest of time, I probably won't take too many questions, because it's a very short presentation, so you can seek me out afterwards. But at the end, if we do have time, we will allow one question that needs to be a mean, harsh question from a skeptic, to show you that I can deal with the hard questions. Either that, or I'll fake it and say, oh, I'm sorry, we don't have time to answer that. Here we go. Also, while I'm looking, our next speaker is, according to my calculations, Heather Wild, is that correct? Yep. Heather, are you here? I am. Okay, Heather, I want to make sure that I'm courteous to you and give you enough time to transition. So do we have the people, someone going to tell me when to stop and everything? So, okay, show that to everybody. When we say stop, when I see that, it's going to be a dead stop as a matter of courtesy to our next speaker. Okay. So here we go. Impact. PowerPoint. I hate PowerPoint. Yeah, I saw the word for best design and stuff like that. Yeah, no chance. I'm limited to like making squares and arrows when I get really fancy. Okay, so back to how you're going to be tortured. Let me step through the presentation to give you sort of a cognitive map of what you're going to see. I'm going to spend the first 2.5 slides reviewing, when I say reviewing, neural networks, because this is where all the action is. I want to make sure that everyone has a common baseline on what neural networks are. And regardless, I bet that everybody in this room is thinking more or less the same thing. everybody in this room knows more about neural networks than I do? The answer is you probably, everybody knows nothing. You're all about at level 0. I'm guessing, although I'll be humiliated if we have some experts in here who point out a flaw in my presentation. Then, the bulk of the presentation is, like I say, the title says 4 things that are sort of going on in research right now. Now, right now that's kind of hard to define, but the key thing here is I want to give you information that's actually useful. Put these things on your personal radar scope so that if you see them coming down the pipeline, you at least sort of have an idea what they are. And one of these is about, typically this will boil down to log file analysis of billions of items in an automated way. It sounds kind of like, I remember the first time I heard this, someone told me log file analysis. I go, great, I mean, can you think of another topic that's even more boring? Yeah. But the answer is it's a very important thing. There are many, many startups in the Seattle area where I'm from that have multiple million-dollar funding rounds for this problem. So that's going to be one of the things that we'll see. Word embeddings. This has been the single key thing that has absolutely revolutionized natural language processing. My claim is that we have essentially solved numeric problems. Nowhere near solving natural language problems, which is just a broad category, but in particular, analyzing documents and things like that. Now, there's one area that we have solved, and that will be explained by this slide. And that means this is something that you can bring to your company, to your enterprise, to your organization immediately and use. And it's not widely known. I'll say, I'm a skeptic on this, okay? But I'm going to point it out and give you the good side in my hesitation. It's called BERT. Yet another. This, I've been involved with computer science for many years, and maybe you have too. And there's been a beautiful connection between the history of chess and science that absolutely made my jaw drop. And I mean it quite literally, but where my heart, alpha 0 and C, the real question here is, what does it mean? The answer is nobody really knows yet. And then here are these last two. I don't know if I'll have time for this because I think they're quite interesting. Neuromorphic computing sounds very cool. And neurosymbolic computing sounds even cooler, and we can talk about goats and voles and stuff. And silence. So this is what the presentation will consist of. Okay, so let's start with, and it's all, I had to start with 0 to show you how hip and cool and developer-centric I am, because if you start with 1, that's just too easy, so I start with 0, I'm 0-based. One of the first questions is, and it's a very hard question, is what is AI, what is machine learning, and what is a neural network? Well, I can't answer all these things, so we're just going to focus on neural networks, because that is sort of the engine that is driving all of these things. And the first question there is, what types of problems can be solved using a neural network or tackled? And in my mind, the first thing I do is imagine a SQL table, whatever you want, and your goal is to predict the value in one of the columns using the value in the other columns. Then you are right in the wheelhouse of the affiliation of people based on age, income, education, and education limiting high income and age. Now, and our goal of this particular problem is to predict the political party affiliation who is male. The first thing down here that is important, do not ever underestimate the difficulty of the absolute vocabulary chaos in this field. It's a huge problem and one that you have to be aware of. From mathematics, from this field, from that field, from the other field. And they all brought with them their own particular vocabulary. And that vocabulary has not unified. And it creates an enormous difficulty in understanding it and also communicating. That segue, I'm a terrible speaker, I really am, because I sort of jump around, and I made my little notes. So I'm going to jump immediately to the 2 key takeaways. Okay? What is that there are enormous opportunities for you. I work in the deep learning part of Microsoft Research. We are completely out of touch with reality long. And I have to be very deep in my field. And what that means is I know nothing about reality, and I know nothing about your world. The key opportunities for everybody in this room are understanding enough about, because you would have to dedicate the rest of your life to it. Where the money is and where the opportunities are is you understanding your business data, your business infrastructure, and your business problems, and being able to articulate that to a neural network or machine learning AI expert, and have enough knowledge to unwind that. So the huge opportunities right now. And the second takeaway is that you should be skeptical. Like anything in technologies, we've seen them come and go and come and go and come and go, and just one thing after another. Whenever there's a new buzzword, be highly skeptical of any company coming in, claiming to be an expert, and just use common sense. And don't think that just because the marketing literature slaps artificially intelligence engine, it means anything or not. So those are the two takeaways. Back to our neural networks. The goal is to predict this. This is a classification problem, but we could predict numbers, or we could predict binaries or whatever. Infinite variables, typically from data scientists group, and so for features, features is the one most common one. Anyway, move on. Now, how does it work? Well, here's a neural network. So if you notice here, there's actually two different kinds of data, which is significant and ties into the first takeaway about the log file analysis. So the age goes and income goes. So what's going on there in sort of I know somebody knows. Don't be shy.
Scaling.
It's being scaled or normalized, okay? And it's just common sense. You don't want very large magnitude values to swamp and overwhelm values. So these are the predictor values. However, some data is non-numeric, and it has to be encoded. This is called hot encoding. Again, all these things have multiple names. And the gender, surprisingly, you might guess that, okay, gender, the obvious way to turn that into a number would be 0 and 1. But it turns out that and that would in fact work, but sometimes -1 and +1 works better. So there are little details, but the point here is do you need to know that? Well, you need to know about encoding and normalization, but you don't normalize and encoded inputs. Now they go in, and this is the neural network. And let's skip over that and go to the output. So there's 3 outputs. Does anybody see the relationship between those 3 numbers? There is a relationship there. These are actual real numbers with that real data. Sum to 1, and that is by design, so that they can be loosely interpreted as probabilities. So we end up with the probability of, do you remember what the 3 possible probability of others? So largest probability, Republican. This also gives you a loose measure of confidence of how, if you end up with some numbers in, numbers out. Neural networks are nothing more than a very, very complex mathematical function, okay? And that's all they are. And from that little seed, large things have emerged. Now this is the actual neural network. And the most complete box that you almost don't even notice is the white lines. Those white lines are the key to the neural network. Each white line represents a numeric value called a weight, and added together to produce the output. It's just a math function. Now, the point here is there's kind of a determined by your data. The number of output nodes is determined by the problem. But the number in the middle, those so-called hidden nodes, those are where the processing occurs. That's sort of just arbitrary. And to make multiple layers. Now, does anybody know what a multiple layer neural network is called?
Deep neural network.
Yeah, who said that? Deep neural, you again. Okay, no more answers for you. You're making the rest of us look bad. A deep neural network is correct. So this fancy deep neural network, all it means is a complicated neural network. That's all it means. There's labels for it, but it does have that effect. You go deep neural network, wow, it sounds very deep. I can't possibly understand it. It just means more surface, okay? And gives you more powerful prediction. But what happens as you either increase this way or increase that way? The white lines, the increases exponentially. It actually increases quadratically, you know, if you're a math person, but it doesn't matter. They get really, the number of them gets huge really, really fast, becomes unmanageable. A real neural network, the little red lines are special weights called biases. They're the same thing. They're determined by the values of those white lines, and those have to be determined by training the neural network, okay? And that's the hard part. So that's a neural network in about 3 minutes. Now, we're just, raise your hand if you can add two numbers between -10 and +10. Raise your hand if you can multiply two numbers between -10 and +10. Raise your hand if you can use calc. Tangent function, which sounds horrible, but it's just a geometry thing, you know, it's really simple. That's all it is. And usually when people hear this and they go, he's dumbing this down for us or some, no. This is what I do at Microsoft. This is it. It doesn't get any more complex than this. This is the absolute base level truth. You don't know very much. Okay, so that was part one of our presentation, which was sort of providing a foundation for neural. I think that I'll be happy, at least from my end, that you know as much about neural networks as any non-technical expert needs to know in order to communicate things. This is a actual project I was working on. And this is a particular kind of neural network called an autoencoder. And gosh, I'll just cut to the chase and say, this represents numbers, which are input. And from the previous slide we saw that these could represent any possible kind of data. It could be labels, it can be words of English or any other language, or it can be numeric values. They all can be converted into numbers in some way. Now, a autoencoder, the input and the output are the same thing. So this neural is a special kind of neural that learns to predict its output. Now, you go, well, this doesn't sound particularly interesting or useful. But it is. Remarkably, first of all, could be applied to anything. This is a universally applicable sort of paradigm. What happens here is all this happens, and you end up, each one of these dots are just numbers between -10 and +10. What an autoencoder does is take any possible data and make a small, it's like, you know, you know all about compression, like image compression. You can compress it down so you can expand it back out. There's lossless and lossy. This is sort of like information compression with it. And what we applied it to in a particular project with the log file analysis. Does anybody work with log files? Oh wow, good. In that case, you see a lot, they know what it is, of course, but they don't have to work with these beasts. I mean, these things are monstrous. They're impossible to deal with. Try to imagine, the thing was, this was a group, I can't talk too much about it, but briefly, they would get on order of magnitude about 100 million entries in a log file per hour, in these manually. This is what they did all day long, every day. I don't know about you, but this is not my kind of idea of fun. And what they were looking for is the weird ones, okay? We'll maybe mention more about it. Eliminate that 120-person team and completely automate it, and it was doing a much better job for essentially free. The way it worked was, you would take each one of these as a log file entry. It doesn't matter what those columns are. It's condensed down, and then you would have a model that would predict its output, but you would look for the ones that are the most difficult to predict. It's called the reconstruction error, okay? And the difference between are significantly different in some way. That means they're weird in some way. They don't match the others. Kind of like closely akin to clustering in a way. It's all developed within the last 12 months, okay? It was speculative, but this is something you can actually apply and if you have log files or anything else similar.
15 minutes left.
Okay, 15 minutes left? Okay, good, I don't want to. I get too excited on this. Okay, so here's the other thing. They'll come up with the worst names for everything. It's like they go out of their ways to come up with names that have no meanings. Has anyone heard, my favorite, in fact, we're going to see it coming up, in fact, it's right here, coming up. What? See, I don't know about you, But to me, embedding is stuffing something inside of something else. It has nothing to do with this because, in part, and this isn't a joke, we're out of touch with reality. We can't make up words that, you know, connect to human beings. We just go, let's call it embedding, and sort of like end of brain activity, good enough. And cutting to the chase here, a word embedding is a way to convert, and I'm going to use the English language, just, but this applies to any language. A word in the English language, words into numbers. Well, you have 15 or so, and they completely change the game for all of natural language processing. Natural language processing before word embeddings looked at words as symbols, and there are many people worked for decades, and they all failed. Nothing worked even remotely close. But word embeddings changed everything, like almost overnight. The vast majority of natural language processing became instantly obsolete. Now, of course, that's a hyperbole and exaggeration, but not much of one. So there's a way to convert words into numbers. And just, this is I ran this actual little demo. It's very difficult to see. So what I did was I took the first two words. This is an actual demo. I have it on my machine. I could run it, but I don't have time. I actually took the first two words from a Sherlock Holmes story. And if you look at it here, there's still some things that had to be done. I converted all to lowercase, removed punctuation and things like that. So there's a lot of technical details. I ran it through, okay, and this is a particular kind of neural network called, and here's the worst name ever, LSTM, long short-term memory. You go, is it long or is it short? And don't try short-term memory. And they did have a logic for it, but trust me, you don't want that. So let's look at from a global perspective. If this is possible, as each word is fed in to the network, we accumulate running numbers. This is a famous example called the IMDb Movie Database Challenge. 3 years ago, someone out of college could do this in their sleep, so to speak. And what the template for the problem is, when you have a sequence of words to a value, where the goal here is a movie review, and is it a positive review or a negative review? So sequence of words to values. Entities in the English language. For instance, here's one that I actually ran, a great waste of my time. Okay? Now, any human knows that this is clearly a negative review. But systems are going to do what? How are they going to get tripped up by that?
Great.
Yeah, they see great. They focus in on great, end of story, this is a positive review. And another thing is that this all this approach takes into account the same word, which is just a nightmare. So anyway, word embeddings and all of this background engine relies on this word embedding. The ability to translate. There's just two sentences here, and then using the word embeddings, I found every number or every word has a vector of numbers. And from those, I took the closest using Euclidean geometry, and it was Holmes. And in fact, it's almost like magic. Holy mackerel. I mean, it's right. If you read through there, he does refer to Holmes, but they're separated by many, many different words and all kinds of English constructions. So in short, this is a done deal. This is something that you can take to your enterprise right now. Imagine a scenario of you get user reviews and you want to score them somehow, a review to a value, okay? Things have been insanely successful. They appear like magic. I could show you demos that really would astonish you. On the other hand, sequence to sequence. A classic sequence to sequence is translation from one language to another. This has really proved. The approach that had been used up until up until about 18 months ago was to use the technique for the sequence to value, where you take a sentence and you munch it, and you have this one number that represents the entire input sentence. And then for us, just too much of a challenge. Okay? So people have been working on alternate architectures. And the one that is the current state of the art, there's all kinds of benchmark problems, it's called BERT, Bidirectional Encoder Representation from Transformers. And it gives state-of-the-art results on these language translation problems. I'll say I'm highly skeptical because for me, it doesn't feel right. The system just feels right. You know, it makes sense. This feels like a monstrous hack. It's insanely complex, one of the most complex software systems I've ever seen. And to me, when things get that complicated, it's a hack. And now, that said, I am in my work group at least, I'm in a minority of one of that opinion. Everybody else thinks, oh, this is clearly a major breakthrough and will become a standard technique. Okay, and I'm going to finish with this one, only because it was the most, the second most impactful moment in my life. The first most impactful moment was when I was a university student. And my university had one of the very first, type it in like clickety clack, 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 clack. And we had one of the very first chess programs. And I grew up playing chess. And when my professor allowed me to play on the timeshare, you know, the virtual money at a quasi-human level of intelligence, just blew me away. And the entire history of computer science has sort of parallel developments in chess. Did anybody hear of or remember Deep Blue and Garry Kasparov, the world champ, one of the two best players of all time? And finally, now, IBM series of tiny little incremental better. And that has continued forever. And now, the best chess programs, the world champion chess program is called Stockfish. Yet another incomprehensible name. The names of these programs are like racehorses, where they take the names from the predecessors that they use and they grab a chunk of this and a chunk of that, so you get very strange names. Stockfish, and every year there are computer challenges for the computer thing. So this was a work out of Google research, AlphaZero. And what they did was, and I'm going to give you the story where every sentence is somewhat of a lie, in the sense that there's more to the story, but the story sounds a lot better if I lie. Okay, so what they did was, they go, okay, we're a machine, the rules of chess, that's it. They gave it no heuristics, no anything. And they just let it play against itself for 4 hours. And then they said, okay, we're going to challenge Stockfish. They knew what they were doing, of course. And everybody in the community had defied this, oh, this is going to be, and sure enough, in a typical match between the very good computer programs, a typical result would be computer program A, 2 wins, computer program B, 1 win, 97 draws. They played one absolute massacre. It was 27-0, okay, which is absolutely unheard of. And everybody, yep, we knew it. And then we all read it, including me, they go, what? AlphaZero had destroyed the culminated effort of the best human minds over decades and decades of computer science algorithms into Stockfish. This was just one of the most astonishing results I've ever seen in my life, and I almost cried for happiness. It was such a marvelous achievement. So, the problem here, what does this mean? This is a very narrowly defined problem, and it's not clear to what extent this type of work can be applied to others. So I'm going to jump ahead to, now what take, who is the grumpiest, crankiest person here? I'm going to volunteer you. You look grumpy and cranky. Yes, well, you stand up, sir, and tell us who you are. Your name? To Americans, if you're not American, if you're Russian or German, or you sound smart. So give us either a comment or a question on the presentation.
Yeah, the problem is the deep learning. I played with this, I wrote my own way to do it, and actually the question is the comprehension, understanding how to do that. It's absolutely impossible to understand, but you have to
absolutely correct, and you hit on what was going to be my next section. And I'll just summarize. First of all, you are absolutely correct. One of the big questions here in research right now is like, okay, with all this, is the machine actually understand? That leads into what was going to be this talk, and these last two slides are forward-looking efforts to completely try new approaches that address the cognition problem. And the one that's being worked on right now by the department, there's some serious billion-dollar funding by the Department of Defense on this approach, where instead of using the numbers between -10 and +10 and all this, it's an idea. Neuromorphic means closer to the input spikes that much more closely mimic, synapses and neurons where there's like pulses, okay, and spike trains. So this is years out, I think. Well, thank you for your question. That was great. Thank you, Igor. I'm glad that wasn't very, and I'm.
That's XD app. A good number of you? Okay, great. If you haven't downloaded it, I would encourage you to. It will be updated every day with room numbers in it, room assignments for sessions. So if they need to change or if we have any changes to our schedule, those will be noted in the app. There are a few additions for sessions today. For instance, we added an escape room challenge this afternoon. So that is a session that if you want to participate in it, there's only 12 spots per session. So you need to be one of the first 12 in the room, but you've got 2 chances to do it this week. So keep that in mind. That'll be this afternoon, and it is in the app. So now and she's going to be talking about anticipatory design. So her session is called Practically Magic, How Anticipatory Design is the Future of Product Development. And I think this is something that if we're not working on it directly, we're likely to be already experiencing it in our day-to-day lives. So it's great to have awareness of it, but I do think more and more organizations are going to be looking at this in their product development. Heather is an award-winning 6-time CTO and 5-time certified executive coach. She was an early employee of Spirit Airlines, a founding member of Evernote, and she oversaw Evernote's growth from a few thousand to over 100 million employees. So she's also worked with the US Navy and NASA and many state and local governments. So I'm really excited to have you here. Thank you for joining us.
Thank you, Amanda. Hello, everyone. That was a great talk. Thank you very much for a great opening. And it was a good tee-in for what I'm going to be talking about right now. So, show of hands, who here has heard about anticipatory design? Wow, okay. Who here has heard about Buckminster Fuller? Okay, so those of you who know who Buckminster Fuller is, or a buckyball, maybe, that is basically, he was the person who, a long, long time ago, started people thinking about anticipatory design science, and that's kind of what we're going to be thinking about today. So, every day, we make 35,000 decisions, conscious or unconscious. And this is, like, these are, did I get the right type of coffee today? How am I going to decide what kind of coffee to get from Starbucks? Like, is this person in front of me going to take forever, or are they just going to get a flat latte? You know, these are the kinds of things that we do, and we don't even realize it. So, a couple of years ago, when this is the hurricane that hit Dominica and completely flattened the country, I was looking at the TV, and I immediately made the decision, consciously, that I was going to help. I wanted to give money, like some of us, a lot of us do when this kind of thing happens. So I went to the farm, And then I continued to fill out the form. And then by the time I got here, I was just like, screw it. Because this is the form for filling out the information to just donate money. This is our fault, people. We are the ones that developed this stuff. So and thankfully, I found something that was easier, that somebody just a few minutes later on the screen said, just text to donate. And I was able, from my phone, to text money, and it connected my Apple Pay to just send money right away. Because somebody anticipated that I was going to have trouble with that form and give up. But I need all this information. And on the other hand, there was somebody that anticipated from your phone, you already have all that information. And that's the difference between traditional development and anticipatory design. Tired that this is a real thing in Google. You could type that right now, and people are asking Google how to Google. It is so hard that this is us at the end of every day. I mean, I don't even have to ask you to raise your hands. I know that you're doing that. Sometimes cause us more difficulty. Let's see if this will work. Do I have volume? No volume. 1 second. Hold, please.
Welcome to spelling class. You will be asked to spell a word at each level. Keep moving ahead by spelling words correctly. Level 1. Can you spell the word climb?
C-L-I-M-B.
Sorry, that is incorrect. Correct spelling is climb. C-L-I-M-B. Let's try again. Level 1. Can you spell the word dinner?
D-I-N-N-E-R.
Sorry, that is incorrect. Spell the word dinner.
D-I-N-N-E-R.
Sorry, that is incorrect.
So, I mean, all of these technologies that we're creating to try and help us are really screwing us up. We're just so used to it that we have websites dedicated to how bad, because we're expecting these things to screw up. Okay, show of hands, and be honest. How many of you scream at your phones, okay Google, okay Google, okay Google, over and over and over again, or hey Siri, waiting, instead of just typing in the phone. But really, it's because you're so used to it failing that you're just accepting it to happen. So we know this, we're developers, we're technologists, we want this stuff to happen. So we create all sorts of things that don't necessarily need to work. Like, does anyone have any of these in their house? Do you know what this is? So it's a dash button. So the idea is kind of okay. I think you're supposed to have this for items that you don't necessarily think about, but you always, like, when you need it right then. So if you've run out of, say, detergent, then, or you're about to run out, then you hit that button and then it's supposed to show up like a day or two later. But it's supposed to train over time, and you're training the machine learning model to learn how you work. Now, Netflix is a great idea, right? It's supposed to give you all sorts of recommendations and all sorts of things to help you spend your time better, and you can find there you're just spending time, about 45 minutes or so, just trying to find something. Because what you're doing is you're training to create so that you don't actually watch anything really good. You're watching stuff that they are creating. And this is all going into 2.5 quintillion bytes of data produced every day. That's like, wow. So we don't have USB sticks that big. We're not going to anytime today. Multiply that out by 7 billion people on the planet. There's so much data that we're not yet collecting. However, it's doing something pretty cool. It's allowing us to predict the future. And that is the basis of devices like Alexa and those dash buttons, and even Netflix. And adding a little bit of really cool use and anticipatory design. Now, before, we had a problem of it being right. There's a high cost to being wrong. Because if you're suggesting something, like early Netflix, the recommendation engine wasn't great. So people weren't to have all those really good A movies. Now, there's a low cost for them being wrong by suggesting that you watch Sharknado 8. Because you're gonna watch Iron Sky 4 because, like, hey, or something like that. You're gonna be like, hey, that's kind of neat. I can waste 2 hours on that. So, in order for you to go from that old way of doing things with old recommender engines to an anticipatory design kind of thing, you need to collect data, and a lot of it. That 2.5 quintillion, you gotta tap into that. And then create some relatively easy algorithms. It's like you're using your old recommender engine kind of thing, but because you have so much data, you can make easier choices. And then you can just simply anticipate what people are going to do. So some cool applications that people are using of this are, this is a book writing software. So this is actually available on GitHub right now, where you can tell it, like, you just start typing a word, and then it continues to write a sentence, and it can do an entire book this way by anticipating what you want of writing different genres of text. These are fill in the gaps of what people are saying to do automatic translation in 200 languages. I just used them on my honeymoon, and it was kind of interesting because it was able to, with noise canceling, figure out, like, basically what people were saying in real-time translation. Oops, wrong way. Here is a good application of anticipatory design because search for a restaurant. It's going to tell you how to book a reservation for it, what tables are available, and if it'll make a reservation for you, so you don't actually have to get on the phone and call anybody anymore. Isn't that cool? And it will allow you to call an Uber directly, or it also connects to a cab company if you have that app installed. And if you open up Uber, another anticipatory assumes that you want to book the Uber from where you're at. It's not asking you all those questions like, what's your name? Where do you live? Because it already has that from your phone. But it's learning what temperature and where your zip code is, so what are the people you really learn as well. This is called Magic. You just text it the kind of things that you need. And it does research for you. And then orders it. That is not a person behind it. We could add additional credit cards, but it just gives you 3 options based on machine learning and I mean, it's doing natural language processing on the words that you're typing to do a search. It's hiding money for you, for those millennials out there that have no idea how to save. It learns from your purchases, your purchasing behavior, that, like, you go to Starbucks on Monday and Friday. So on Tuesday, Wednesday, and Thursday, we're not necessarily going to notice it because who actually looks at their bank account balance? Does anyone? Really? Yeah, $50 in your bank account just from not going to Starbucks. And it does things like that. This is a product that has been canceled at Google, but they do a lot of things like this. They're anticipating gestures and learning, like, what do people do that they would expect to be doing to learn for future products. So, like, do you expect to turn a knob or things like that? So expect to see something like this coming soon in a Google product. This is one of my own projects. We're together on travel. So, like, finding people that are like-minded in personality to four people in cabins on a cruise ship for 16 days each through this algorithm. And it worked out really well. So this is an example of anticipatory. One is that when you are logging in, instead of saying forgot password, it's saying into someplace you don't have your password. So instead of, it's just telling you email me a link. So it's saving you 3 steps, and I do this all the time.
And there was this toy. It was going the dragon, unicorn, or no, dragoncorn? I don't know.
Find something and you don't know, you want to price search for it, or like your kid's birthday party and your kid decides they have to have that thing but you have no idea what it is, or you're trying to find that latest Paw Patrol thing, like, take a picture of it, Amazon will find it. This is awesome. So there's the connection of it, and it will, over time, tell you if you have changes like in moles, in weight, in all sorts of things to notice, and it can predict whether you have a likelihood of gaining skin cancer or other to do things without your interaction. A bike, if you like to, if you're a cyclist, without having for you, if you want to ride on cobblestones, if you're changing to a mountain bike or street bike or something like that, you just have examples of the way that anticipatory design can work for you. And it also tracks for you, so you don't have to have Strava, you don't have to use all these other apps because it's tracking everything for you in one place. Now this doesn't exist yet, but it was in testing at CES last year, that it is a pod place, one person's going to another place, and then it just tells you on the screen, like, it's this person's place to go out. So it's an automated buy. They do it in one person per pod, and then the pod just stops. When common is people are primed to use them. They're not if we already are aware of it. We're not willing to try something necessarily if it's a new category. We're not likely to do it. However, if the predictions are wrong, very wrong, Target is very far ahead of the curve with anticipatory design and machine learning. They are inferred based on purchasing data that one of its guests buying elevated rates of buying unscented lotion, baby gear, much to the consternation of her father, dark about his 15-year-old's pregnancy. So he sued Target, and their machine learning model was correct. You're using this properly, you can get people, you can let people know, like Target did, that does, by letting you know, hey, we have a coupon available for you. Like Target does, we have a coupon available for you. But now Amazon is doing amazing things with us. One of the things that they have done very well is recently they've been getting 1 day and 1 hour shipping for their most popular products in a specific region. And they even filed a patent to get this down even further. What they want to do is to be able to have an item on your doorstep basically at the same how they're doing this is by testing to see what are the most popular products, what are you looking for online, what are your purchase intent, all sorts of things. And that's how they're shipping area. That's what is basically in the local distribution area. And you'll probably find that almost everything that you would want is in that already, like the daily things that you would want. However, yet, until people are more comfortable with the idea of, if I hit the button in your company, put this into practice. Like if you are doing this, or if you're thinking about doing this, what do you do that has a service? Like it has to have an IoT kind of component. Like you can't just be a single person that's doing that. Not that any of you really are, but you have to have some kind of service, like Amazon, that can deliver things, or Digit, that is a financial service company that can be taking people's money digitally away. Then there has to be some kind of digital access. If there is a digital access, then it is like you can now collect data part of any anticipatory design thing. Because without that access to that quintillion section of data, you cannot get it. Then you have to be automated because it's helping you out. Then you have to be automated. So that service that you started out with, you need to come up with a way to automate it and continue to keep it automated. And then here's the most, this is based on taking choices away from people. Like in the very beginning, my example used a form that had all of those fields. But the one that I went through was text this number and that by giving my money amount, that it would be fine. So they had to, that second, so you have to figure out for your company what ethically you can take away to make it still easy, because like with Google and their gestures that want some kind of way to access it with some kind of menu that isn't gesture based, but they're going to take that away. There isn't going to be one. Like with the Nest, there's like a hidden menu for pros and stuff, but even with that, there's will be like delivering the service that you want. Then you need to analyze what is the data that you're getting back. And if there are outliers, I always pay attention to the outliers, not that something is going wrong somewhere. And when you, like with anticipatory design, you've taken away choices. So if people don't have choices, then they shouldn't be making choices that would cause outliers. Constantly be coming up with ways to streamline. They went from a minimum of 3 steps on the forgot password process down to 1 on the login. So if that's now 5 steps in your site, in your service, in your company, everywhere that is causing multiple points of friction, that is a place where you can improve. And remember that whatever you do have should add value. So again, with Dominica, with the donation, the one thing that they did keep was the most important of how do I get the money there fast. And it worked. And I did get I even got a donation confirmation receipt for my tax return. So it was all in their system for everything. Please pre-populate your forms, people. Like if you send somebody an email, this is one of my pet peeves, that has their information in the email, and then you click through, and it doesn't have even their email address in the email address field on the form, it's easy. Like you should be able, I mean, there are secure ways to obfuscate when you go through for the token. It is so easy to do all this, but people are like, oh, no, because it went through intercom, I can't do it that way. Yes, you can. There's ways to do it. So here's a glimpse of the now.
Smart things. Life like never before.
So if we can do all that now, I mean, was anyone at CES this year? The Jetsons are here, man. I mean, they've been promising that since my parents were here. Ability to create these experiences in vision fatigue that we have been dealing with for the past 15 years or so, that we've forced upon ourselves. So we can go back to this, like, we can go forward to thinking about new technology and think about is what are we able to take away without losing our integrity. So all of those things, if you're interested in learning how to create them, how to build them, how to integrate building, start playing around. And it doesn't matter what level of technologist you are, even if you're a marketer, there's some of these things that are really easy to start with. Even the least technical person in this room to go out and get a Raspberry Pi and start playing around, because they're so fun to start automating things and seeing what's possible. But I want to thank you for having me here. And
the slides are going to be available for us.
Okay, you talked about the constant analysis to improve it. How is that analysis done accurate?
So there are tools available for, there are thankfully machine learning tools available to do constant analysis. And but they can also give you reports that are even in natural language. Like Quill is a great one that I use that tells you here's what happened on this day.
Hello. You mentioned outliers. You should outlier if there's something wrong. But it's not always. Sometimes it's an early indication of the change.
Yes.
You know, and what's outliers now could be more later. This is anticipatory example I give. Seeding immediately goes to prepare my drink. But I don't want to this particular drink. I don't want to give to drink heals anymore. But
yes. So so one of the things that the Starbucks model has done is they have an anticipatory model where in the mornings, so they actually have a model and a test that they've used where they will prepare your drink for you before you get there. in some stores, and then they'll send you a note saying, like, hey, we'll leave you 50% off your drink if you want, then they'll just trash it and you can order another one. And then they're using that to train their model as well. So for example, like with that, like I have a drink that I order in the morning and another one in the afternoon, but they had to trash a whole bunch of ones from mine. And I noticed that my name was on some drinks that they would just pull back before I noticed that. So yes, that's one of the reasons that I always recommend that you pay attention to outliers, because like when you're doing this kind of model, the people that are paying attention, I mean the people that are just following the thing as the people that are just happy to not have to make a choice will be fine. But the people that are most useful data are the ones that will fight you.
See this in your experience unfolding from a product management perspective on a regulated industry like financial, and I come from a data science company. Yeah, we don't have your data integrated with your Apple Pay, right? So a lot of the things like simple doesn't really like work simple in a regulated industry. And how do you see this unfolding from that context?
So take away for your own industry. In Target, they used the data that they have, and they've figured out ways that they can. In logistics industries, they're figuring out what they can pre-order for their own companies. So whatever data it is that you are able to collect, you can run predictive models on that, and then you can make it easier. Maybe it's just internal. Maybe it's not your external company. Customers. So you just have to figure out what data you do have for HR people to onboard. If you have the ability, everyone has what those pain points are.
I got a question, and this is more about the anticipatory design. What's the risks that a company would have for setting up like different venues and different options and things like that to marginalizing people with accessibility options or disabilities or the inability to use what we anticipate?
Yeah, so that's a great question. One of the things that I've found with when you don't have tiny buttons to press or more fields that you have to fill in, and you're leaning more towards speech recognition, and like voice recognition tools and ability tools into it, and making sure that so yeah, these actually flow. Like every single one of them passes pretty much any accessibility test you'll throw at it. So that's a great thing to keep in mind when you're designing as well.
I got a question. Like, there's this kind of stuff that's going to reduce jobs right out there over time. So I'm wondering, for those people, you know, who are working those jobs, what would be your suggestion of what they're going to do with the machines take over?
That's a great question. I actually have so the jobs that exist right now definitely are going to change in the future. And, but there's going to be a new class of, because people want to deal with a human face. They need critical thinkers. We're always going to need creatives. We're always going to need a person somewhere to talk to. And so while we're taking away like the low-level knowledge worker skills, we're adding back in jobs and places for people to be human. And I think that's something that we haven't really, and it's probably gonna hurt for a little bit, but I think it's gonna be a really cool world.
Question related to anticipatory design. So it seems the key word there is anticipate, and some biases that affect maybe the judgments that go into AD when we're or self-correct once detected.
I think that the main thing that we can do is add more people into the model, like more and more people to train that model. It will self-correct. So so for example, the first anticipatory hand cleaners enough, they only looked for hands like mine, but now they have corrected, they're getting better. because there just weren't enough people to train that algorithm. But we are getting better the more people we add to the model. So thank you very much. I've enjoyed being here, and I hope that the rest of the conference is good.
Are going to go into a break now. We have about 15 minutes. There is coffee and snacks outside if you needed an incentive to stretch your legs.